Okay, Specialist Maths Paper 2 Tech Active from 2023. We're on to the last question, question 19. Oops, sorry. Question 19 is a stats question. So it talks about the height of Year 9 students at a school is assumed to be normally distributed with a population mean height of centimetres. A teacher at school measures the height of all students in her Year 9 class. This data was used to calculate a 95% confidence interval, which we can see it's there. The teacher repeated the procedure using data from another Year 9 class. Although this class had the same number of students, the data produced a 95% confidence interval, and it's different. Using the same data, the teacher recalculated the approximate confidence intervals for for each class using a confidence level of X%. She observed that the upper bound of the confidence interval from her Year 9 class now equaled the lower bound confidence interval from the other Year 9 class. Determine the value of X, give your answer rounded to 1 decimal place. Okay, very, very wordy question. Okay, but like it's a hardie. So look, we know it's normally distributed. Now, let's talk about, I'm going to talk about it being Class A and Class B. Note that each class has the same number of students. Now, let's first off, we've got a 95% confidence interval. Gives me a Z-score of 1.96. Good starting point. Class A, if I want to find the sample mean for Class A, it's the middle of this, isn't it? So to find the middle, 163.7 plus 166.9 divided by 2. Let's go to my calculator. Oops, I'm in stats mode. I need to go back into my run mat mode. So I'm going to go 163.7 plus 166.9. I realise I haven't bracketed it, so let's just add it. Divided by 2 is 165.3 for Class B. So using this data to find the mean, sample mean I should say, shouldn't I? 4, add them together, divide by 2. The other way I could have done it on my calculator is divide 167.8 plus 172.4, close my brackets, over 2. Look, we're getting there the same way, and we get 170.1. Okay, everybody's happy with that. We can find thing, obviously, I've called this A, this B, and I've called this 1, this 2. If you want to go call it A and B, would that be more consistent for you? Probably would be. Let me call it A and B. Or you could have called it Class 1, Class 2. Doesn't really matter, just that distinguished so we can know what we're referring to. Okay. Oops. Now, that's for our sample mean. We don't have our sample deviation. Now, if we look at our rule sheet, confidence interval. So let's say, so for Class A, it is Class A, 163.7, 166.9. This will be X bar A minus Z S A on square root of n. This will be X bar A plus Z S A on square root of n. Now, we know that that sample mean is 165.3. We know Z is 1.96 because it's a 95% confidence interval. I don't know SA, and I don't know the size of my sample. Over here I'm going to have 165.3 plus 1.96 SA on square root of n. What we are trying to find, we've got two unknowns, so we can't find both, but we can find an expression. Which do I want to work with? Does it matter? I can either work with this and this, or I can work with this and this. It's just a choice. It does not make a difference. So let's go with the first one. 165.3, take 1.96 SA over square root of n equals 163.7. We happy with that? What I'm going to do is take that over, negative 1.96 SA on square root of n equals 163.7, take 165.3. I'm doing this quite tech active-y. I know you could jump in with your calculator earlier, wherever you're comfortable with that. You're just going to do what you're comfortable with. You can see what I'm trying to achieve here. So negative 1.96 SA over square root of n gives me negative 1.6. Oops. Moving over here, so SA over square root of n is negative 1.6 divided by 0.96, which equals 1.6 divided by 1.96 is going to give me 0.816. So square root of n. Oops. So we have this little expression. We don't know what, oops, the standard deviation will be for that particular confidence interval or group. We don't know what n is. We know n is consistent for both classes. So we did that. Okay. We're going to do the same thing for class B. Okay, so doing the same thing, class B. Now, this was like full working. Let's simplify a little. Class B, let's pick which one we're going to work with. I'll work with the first one. It's uneven to write on. So on the lower end of my confidence interval, that's going to be x bar b minus z s b on square root of n equals 167.8. Okay, so I'm just taking this lower one here, going straight in, not showing both sides. So that is, my mean was 1.70.1, take 1.96 SB, square root of n, 167.8. Okay, that's negative 1.96 SB on square root of n. Let's move it along a bit and we will do on our calculator 167.8. Take 170.1, negative 2.3, SB square root of n divide that across, divide the negative 1.96 across. Divided by negative 1.96, 1.17. Okay. Handy. Probably spread this out a bit much. I'm going to run out of room, aren't I? I do like to spread out my math when I do it. Now we've got this new situation. And it's got a new confidence interval. It's not a 95% confidence interval. But my new situation is when I have my x1 minus z s1 on square root of n x, I should call them xa plus z sa on square root of n. That's one confidence interval. The next confidence interval is xb minus zsb on square root of n. And b plus zsb on square root of n. Now, in my new situation with my new confidence interval, so I'm going to have a new Z score. These two are equal. Okay, that's where we get to, that those are equal. So now what is Z bar A? So that's 165.3 plus Z times SA over square root of n. Remember, I worked it out here. 0.816 equals XB 170.1. Take Z times ZB on 1.17. Fantastic, isn't it? Got a nice rule here. Comes out we've only got Z's. So these we could expand and put in. Okay. I could do it long way. I'm feeling like this question's taking us a long time. Let's go solve n. Just put the calculator so you can see it next to the question, hopefully. 165.3 plus x times 0.186 shift equals 170.1 minus x times 1.17, close my brackets, equals, and I get sorry, I have done this before. Oh shoot, you know what I've done? I left off a decimal place here. Apologies. That should have gone to 3 decimal places. It will throw it out. You probably would get marked the same. But I'm going to take it to 3 decimal places, which I did with the other one, didn't I? Because I did 8.816. Sorry, you can see I'm just playing around with my solve n. As you can tell, I have done this question before, so I do know what I'm trying to expect. And that's what I wanted. So Z equals 2.413. Okay, took us a little bit to get there. And realised I had put that as 2 decimal places instead of 3. I should have been consistent, shouldn't I? Now, what does this all mean? So in a normal distribution, where the mean is 0, 2.413, negative 2.413. What kind of area am I getting there? So I want to work out what percentage my confidence interval is. So I'm going to go to my stats mode, distribution, normal, NCD. I've actually been playing with this before, as you can tell. My lower is 2.413. My upper is 2.413. My standard deviation is 1, because we're just talking about our regular standard. My mean is 0. Execute, and we get 98.4. And then that is my confidence interval. My confidence interval is 9.84. How is this marked? I know they do give you a mark for knowing that, which I think is great. For finding out both your means, you get a mark. Over here, for having these equal, you get a mark. For working out your Z, you get a mark. Working out your 9.8, you get a mark. And you would have got marks for working these out as well, I imagine. Anyway, you can tell that when you look at the ISMG. Anyway, that's the end of question 19.